What is the primary superpower of the functional programmer? Hello, my name is Eric Normand, and these are my thoughts on functional programming. So, I'm organizing this book, and my editor asked me a really good question. It's just a prompt, like a prompt to help me think about my material. The question was, what are the superpowers that you need to teach? What abilities and skills are people going to have after they finish, the chapter, the book, the section? And so I've been thinking a lot about the superpowers, and then what's the most important one, and which ones, how do you organize these superpowers to be taught? And the primary superpower, as far as I can see it, primary meaning like it's fundamental, the other ones all stem on this one, is the primary superpower is the ability to see actions, calculations, and data. So real quick, I have other episodes on what these are, and I could spend a whole hour talking about the difference between actions, calculations, and data. But real quick, actions are things that affect the world and are bound in time. That's how you tell that they're an action. If it depends on when you run it or how many times you run it. So if you send an email twice, that's different from sending that email one time, and it's different from sending it 0 times, right? So that's actions. Now calculations, you can carve out parts of your program that don't matter when they're run or how many times they're run. All the additions that you do in your program, when you add 2 numbers, that doesn't matter when you do it. You're going to get the same answer no matter what. And then inside of that, there's data. And data definitely doesn't matter when you run them. I mean, you don't run them. They're inert. They can't be run. What they can be is interpreted. And in general, we're dealing with immutable data you don't change. And so it's timeless in the way that in a deeper way than calculations are, because calculations do require you to run them at some time to use them, whereas data is just inert. It just sits there, and regardless of whether you read it or not, it's going to be there. Okay. And so the ability to see these things, to distinguish between them, is very important in functional programming. You need to be able to see that this action depends on time, or this part of my code is timeless, and I can run this as many times as I want. So that's the primary superpower. And if a functional programmer couldn't do that, if a programmer couldn't do that, I couldn't call them a functional programmer. Like, that is very important. And I've really been thinking about whether that's true, whether this is primary. And I can't imagine a Haskell programmer who couldn't do this. I couldn't imagine a Clojure programmer who couldn't do this. This is just basic to every other skill. If you cannot identify that this part of the code is going to have an effect, a side effect, that it depends on how many times I run it, versus this other part is a pure function, I can call it as many times as I want, versus this is just some data that I'm going to interpret in different ways in different situations. I think that I'm onto something. But I need your help and to let me know, does this make sense? Like, I would love to hear that it doesn't, because I'm writing this book and I don't want to put this in there if it doesn't make sense. Is there something even more fundamental than that? I mean, I think it makes sense. What I'm wondering is if it's primary. Please, if you have any thoughts on this, you can reach me on Twitter at Eric Normand with a D, and I'm also eric@lispcast.com by email. All right, thank you so much. I'll see you later.